Hello, welcome, and thank you for being part of WorkSafe's Managing Exposure to Silica in the Construction Industry. Hi, my name is Rob Kelly. I'm the Deputy Commander of Field Services here at WorkSafe, and I'll be host for this session. Now, today I'm joined by three experts from WorkSafe. First off, we have Program Manager Perdita Dixon. Hi, Perdita.
Hi.
Next up, we have Principal Hygienist Halil Ahmet. Welcome, Halil.
Hi, Rob.
And finally, we have Senior Construction Advisor, James Webster. Welcome, James.
Hi, Rob.
It's great to have you here today. Crystalline silica is a natural mineral that can be found in construction materials like concrete, mortar, bricks, tiles, and engineered stone. If you are cutting, grinding, or polishing these common building materials at your workplace, did you know that the crystalline silica in these can generate dust and may lead to deadly lung disease and a range of serious health issues? As an employer, you're required to identify if you're carrying out high-risk crystalline silica work and implement controls. Now, today, we're going to focus on three key topics with our speakers. First up, exposure to the very fine crystalline silica dust can lead to serious health effects. Secondly, we'll then talk about what the crystalline silica regulations requires employers to do and how to control exposure. And finally, in consultation with your workers, determine the highest level of controls available to you and implement them. After that, we're going to open up to you, the audience, for questions. And we're going to do that through our Q&A box, which you should see on screen now. But in the meantime, let's hear from our speakers today. Now, Perdita, I'm going to lead off with yourself. Can you explain exactly what crystalline silica is and why is exposure across Victorian industry such an important issue?
Thanks, Rob. Crystalline silica is a naturally occurring substance, and the most common form is quartz, but there are other types as well, such as cristobalite and tridymite. The reason why this is so important is because exposure to the very fine crystalline silica dust can lead to severe health effects, which include silicosis, which is scarring of the lung, which can result in severe shortness of breath and is not reversible. Severe cases can result in complications leading to death. Scleroderma is a group of autoimmune diseases causing hardness and tightening of skin and connective tissues. Exposure to crystalline silica can also lead to lung cancer and kidney disease. Disease from exposure to crystalline silica is occurring in Victoria, and unfortunately, last financial year, there were over 108 silica-related claims made to WorkSafe Victoria. A significant number of these claims are coming from those working with engineered stone. However, there are claims for the construction industry as well. It is unknown what the true number of silicosis cases are in Victoria in all industries, which is why the crystalline silica regulations are relevant for everyone, including construction.
Thanks, Perdita. I'm going to stay with you. You mentioned about construction industry there. Just why is crystalline silica exposure a hazard in the construction industry specifically?
Well, crystalline silica is present in many natural products, such as sand, which then means that it is found in a lot of construction materials. So normally it will be quartz, but sometimes you can also find cristobalite in these products as well. So some of the common construction materials that you would find crystalline silica in are bricks, tiles, grout, concrete, and autoclaved aerate concrete materials. We also know that there are common activities in the construction industry that produce harmful levels of fine crystalline silica dust, which can potentially result in people developing a silica-related disease.
Thanks, Perdita. I'm actually going to come to you in a second, Halil. But first, I just want to have a quick look at the poll as the results are coming in. So what we're seeing at this stage is 301 people have responded. So thank you very much for everybody who's had an input so far. And what we can see there is 39% say that they are dealing with or being exposed to silica dust on a daily basis. We can see 14% is 2 to 3 times a week. 12% is weekly, and infrequent use is 35%. So thank you very, very much for everybody who's put into that so far. So 39% of people believe that their workers are exposed to it on a daily basis. Lil, I'd like to I suppose, go back a step for a second. So we can see, as we said, 39% believe that they're exposed daily. How is crystalline silica dust generated? How does it get into the air?
Yeah, thanks, Rob. when we take material that contains crystalline silica, such as what Perdita referenced before in terms of your bricks, concrete, mortar, tiles, etc., and we use some tools or power tools to generate dust, that we generate dust from those items, we're generating crystalline silica dust in the air. We're generating the particles, they're in the air, the particles contain crystalline silica dust. Now, what we're doing is we're processing the material. Now, by processing, I'm talking about crushing, cutting, grinding, drilling, those sort of activities on the material in commonly found in construction industries. So those processes generate the fine dust. And with crystalline silica, we're really talking about the particles that can do harm. We're really talking about the respirable particles, what are referred to as respirable. They're really fine particles that can reach the lower parts of the lungs and cause the harm. So that's what we're talking about, the respirable particles.
So you mentioned, I think we use the word that the fine dust that you said about getting into, is it the lower parts of the lung? It can get right in there. It's hard for the body to get rid of it.
It is. The smaller the particles, the deeper they go into the lung, etc. Yeah. So
thank you. We've mentioned the word exposure there before, and I know from some other hazardous substances there's a thing called an exposure standard. What's the exposure standard for silica dust, and how does that relate to the high-risk crystalline silica work?
Yeah, the term high-risk crystalline silica work is a term specifically in our regs, and the exposure standard, when the material is processed, the dust is created. It's a fine material, as I mentioned. It's referred to as the material of concern is the respirable particle, so the respirable crystalline silica, RCS. You may hear of it in industry. Now, Safe Work Australia publishes exposure standards, and they have got an exposure standard for RCS, respirable crystalline silica, and it's 0.05 milligrams per metre cube, which has been determined to be sort of the safe average concentration measured over an 8-hour day, 5-day week, to which people can be repeatedly exposed to, if you like. So remember, going back to high-risk crystalline silica work, that's what the regs talk about. Now, high-risk crystalline silica work is actually a process involving a crystalline silica substance where the airborne level, or the level in the air where an employee is working, is likely to exceed half that exposure standard. So I'm undertaking a process, cutting concrete, for example, and I'm generating dust in the air, and if it exceeds 0.025 milligrams per metre cube, so half the standard, then it's regarded as high-risk crystalline silica work. However, you can't consider any controls that you've got in place when you're determining whether you're likely to be high-risk crystalline silica work. I suppose the simplest example I can give is someone's doing concrete cutting. We see it in the streets, see it in factories, etc. When they're doing concrete cutting, they would normally have it water suppressing the dust, so that there's very little dust escaping, or on-tool extraction. Now, that's a control. Now, the regs say in determining whether you've got high-risk crystalline silica work, you can't consider the controls that you've got in place. So that essentially means you need to look at your process. Normally, you look at it with the control in place, but you take away that control, and you'd imagine that there's a lot of dust created in that sort of process. So you would be exceeding half the exposure standard, and that process would then be regarded as high risk crystalline silica work. Now, employers and self-employed people shouldn't be looking at the term high risk as a negative. It's simply describing a situation without controls. An inspector can walk into a workplace and controls can be in place, and they'll look at the controls and not ask for anything more. But it is about putting your controls in place. It's simply a term to describe a situation, high-risk crystalline silica work.
Thank you.
Hope that makes sense. Yeah.
It does indeed. One of the sense I get is when we start to talk about numbers, if you're not sure yourself, it's get advice, whether that's from a technical expert like yourself, like a hygienist, you find out is the way to go, is the takeaway.
Yes.
We talk about regulations there. So Perdita, I'm actually going to draw you back in here. Why were the crystalline silica regulations introduced? I suppose the question is, why was there a special need for these particular rules?
Thanks, Rob. So we know that there are tasks across all industries that produce harmful levels of silica dust. So WorkSafe Victoria took action and introduced the crystalline silica regulations. These regulations support the hazardous substances regulations, which require a number of things, including, like Hillel just mentioned, that exposure to crystalline silica is controlled as per the hierarchy of controls. If silica dust is produced at or above certain levels, and that health monitoring is needed if exposures at the workplace is reasonably likely to result in an adverse health effect for employees. These regulations have been in place for many years, and the crystalline regulations further the aim to minimise Victorian workers experiencing silica-related diseases by these new legislative requirements.
Okay. Hillel, I'm going to draw you back in here now. So the regulations talk about risk assessment. And some people may see that as, time-consuming or even particularly confusing. Is that the only option available to employers?
Well, it's one option that's available in the regulations, and it can be a little bit confusing, and it can be a little bit time-consuming, as you said, Rob. But because the regs require you, if you go down the path of a risk assessment, to consider a number of factors. So you'd have to look at the specific task, look at the duration of exposure, the frequency of exposure, whether the substance, the levels of crystalline silica in that material as well. So it can be a little bit confusing, a little bit time-consuming as well, as you say. But that is only sort of one option in undertaking that sort of task. So
it sounds like there's a fairly big list of what to do. So what should an employer do in that case with all that information before them? What should an employer actually do?
Yeah, like they need to consider essentially what I mentioned before, is this specific task likely to exceed half the exposure standard when it's being undertaken without controls. Now, a lot of processes, if you're working on crystalline silica processes, activities, material, and you're using a power tool, more than likely it's going to exceed half the exposure standard. So the regs allow you not to go down a path of considering all of the factors that I mentioned and simply looking at it and saying, well, I'm going to identify the process that my employees undertake as being high-risk crystalline silica work. So that's deeming it essentially as high-risk crystalline silica work, and then essentially looking at the controls. You remember it's labeling it, and that's what we're doing. We're labeling it as high-risk crystalline silica work, but the essential aspect of it is really looking at whether the controls are adequate. So wet suppression and on-tool extraction, those sort of factors.
Thank you. James, I'm going to draw you in now. Thanks for waiting patiently. You know the construction industry well. It's a sector that employs a lot of people across a range of workplaces and sites. I think it may be fair to say some people may see paperwork as not a priority. So the question I'm asking you is just how easy are crystalline silica hazard control statements to fill out?
Yeah, great question, Rob. So crystalline silica hazard control statements are relatively easy to complete, and this concept should be pretty familiar to the construction industry. We've been working with SWMS or safe work method statements for some time now. So crystalline silica hazard control statement only needs to state a hazard, state the hazards and the risks associated with that work, describe the control measures and how they are to be implemented. So they are not similar to a SWMS. And remember, this is there to benefit the workers. So keep it simple and keep it effective is my advice.
Thank you. And I got a final question for yourself as well here, and I think it's probably pertinent to the employers in the audience today. If you are working with crystalline silica, what control measures are out there? And I'm assuming there's going to be a range of things you can actually do to control exposure.
Yeah, definitely. So thankfully, over the last few years, technology has improved and has become more readily available on the market. So there are a lot of solutions on the market, M-class vacuums, H-class vacuums, a lot of on-tool attachments, as well as water suppression. So my advice here is go out, do your research, speak to a number of representatives from different manufacturers and find out what works for your workplace. This is your workplace, you know it better than anyone else, and have a range of solutions there that you can choose from.
Thank you. So I suppose we've spoken today about what crystalline silica is, how it can create dust, the requirements of the regulations on employers to control the risk, and what type of risk controls are available to them. I suppose in some ways that's a lot of information for people to take away and consider for their particular workplace. So Pradita, I'm going to come to you in summarizing. What are the key takeaways you want people to be thinking of and actioning pretty much straight away?
Well, first of all, understand if the products and the materials that you're working with actually contain crystalline silica. That's the really key first step. Then understand the tasks that are happening at your site. And what are your employees doing? So really understanding those tasks to understand if that fine dust is getting produced. Then, as Halil spoke about, think about, are you actually undertaking high-risk crystalline silica work? And then thinking about the controls, as James mentioned. So in consultation with your workers, determine what the highest level of controls you can use for your workplace. There's a number out there, there's a huge variety, and understanding the work that you're doing is really key there. If you're getting a bit lost or you don't know, the WorkSafe Silica website has a lot of information on it. But also, if you then find that you still need more information, engage someone who's got that technical knowledge. Engage someone who knows what crystalline silica dust is and how to control it. So someone like an occupational hygienist can help you with this as well.
Thank you. I'll say thanks now to the panel because we're about to open up to audience now for the questions. So we're going to get into the real work now. So just bear with me and we start to get to the questions. All right. So first up, and it's had a lot of ticks against it. When is air monitoring by an occupational hygienist mandatory? Halil, I'll put that one to you.
Yeah, thanks, Rob. There's actually a specific regulation in our hazardous substances regulations that covers this. It's a very straightforward requirement. The regs state that the mandatory aspect, as you say, is in relation to where there is uncertainty. So if I'm sure that exposure is really high, I should be going straight to controls. If I'm sure that exposure is really well below the exposure standard, then I should be, I'm fine. But it's the uncertainty as to whether exposure is likely to exceed the exposure standard. So that's the 0.05 milligrams per meter cube that I mentioned earlier.
Next one up is, would you deem it appropriate and reasonable to enforce the use of P2 fit-tested masks and enforce shaving for workers who are just drilling into concrete? Again, I'll probably lead in with yourself, Halil, and potentially James from your construction background.
Yeah, James actually mentioned that the tools that are available now, there's on-tool extraction that could quite easily accommodate this type of activity. And there's more and more of these types of equipments that are available. So in accordance with our hierarchy, we'd be going to the higher level. So you'd be saying, look at engineering controls and different controls before you start looking at PPE. If we walk into a workplace and everyone is in a respirator and they've got sort of an on-tool extraction for this type of device is available, that's where our conversation would start. So if they've exhausted all of their higher order controls and still they need respiratory protection, then respiratory protection would be appropriate and fit testing would be appropriate in that sort of situation as well. But certainly the first option would be to look higher up the tree than PPE, your last resort.
I think that's a fair point there. That what I twigged there when you said that was the question was about a P2 mask, which seems reasonable, but you went straight to the, well, actually, no, there's a higher order control there. There's something you can do better, and that's reasonable. James, from what you know of the construction industry, that aspect of, hey, yeah, you got masks, but it's reasonable to go higher up the line. How prevalent is that out there?
Yeah, it's quite prevalent. But yeah, I think it's fantastic to be framing these conversations at the higher order of controls, and definitely engineering controls are readily available. Yeah, so I have nothing much more to add than what Halil's provided.
Thank you. Next up, we have, as an electrician drilling infrequently, a few 6 mil holes here and there into bricks or concrete, what is the minimum PPE requirement? Halil, I'll probably again lead to you. They seem to be getting the technical aspects.
Yeah, I'd still be looking higher up the tree than PPE. I'd still be saying, look at tools that can extract the dust that's being created. And then if you've gone as far as you can and there is still an issue or a concern, you can start looking at your PPE. And for that sort of short duration task, implement your on-tool extraction, but then you can go to a P1 or a P2. But the fit is critical. As soon as you go to respirators, the fit becomes critical, which means that you need to be clean shaved. If you've got any facial hair, it's going to interfere with the fit, and you won't get the full protection that the respirator offers as well.
It's an interesting point there you make about the fit and the P2 masks. If I do have a beard, I want to work in construction and I want to do this type of work, is there any other equipment I can use in that regard?
Yeah, I'm saying yes, but James is nodding, so I'm going to hand this one to James.
Yeah, it's a good question. So there is other equipment. So we look at a positive air purifying respirator. That is what I like to refer to as that Darth Vader style hood that blows in fresh, clean air that has been filtered. That is at the PPE level, and that is an option for people who have beards like myself. So that might be something to consider to weigh up which way you want to go.
I think the important point again to make is it's still at the PPE level. It's still down the bottom end. Even though you may have a beard and wear it, it's still down the bottom end. And that's not what we're really wanting here. Thank you. Next question up is, how would an employer know if a task exceeds half the exposure limit or the exposure limit without an occupational hygienist? Again, Halil, I think this one's for you.
I'll tackle half the exposure standard first. And really, the levels that we're talking about at half the exposure standard are very low. So if you're generating some dust through your process, if you need wet suppression to suppress the dust, if you need on-tool extraction, but if there's a little bit of dust in the air, it's likely to be exceeding half the exposure standard. So coming to the exposure standard, so double that number, 0.05 milligrams per meter cube, there might be uncertainty. And really additional controls above the exposure standard, really you need to be a little bit more confident. So you need to understand if there is uncertainty, you can engage an occupational hygienist to come out to your workplace to arrange some personal monitoring on your employee. So attaching it to the collar with a battery running throughout the whole time, drawing in the dust, and then that gets analysed after the task to determine how much exposure someone has actually had. So that's easily done over a shift as well.
Okay. David, I'm actually going to put this one towards you. Do you consider core drilling of cement or concrete as cutting or grinding?
So if you look at the crystalline silica processes, which is part of the high-risk crystalline silica work, it's the use of the power tool. So, or if you look at what the core drilling would be, it's not just confined to cutting or the grinding, it's actually the use of those power tools to produce the dust. So it would definitely be captured under those crystalline silica processes, which then would lead you to that determination and identification of your high-risk crystalline silica work. So is it cutting, is it grinding? But it's definitely in for a crystalline silica process.
Thank you. I'm going to stay with you on this because I know your background. How do we find out what are the right controls to be using? So there is a huge amount of information available out there with what controls are available. And so I think it depends on the task. So, we're here talking about construction today, and I think everybody is aware of the fact that there are multitudes of different bits of machinery and tasks that get used in construction. So if I'm using, for example, a jackhammer, or if I'm actually in an excavator, there's obviously really different controls for each of those tasks. So I think it's looking at what information is available out there. And as I mentioned, the WorkSafe Silica website has got a lot of info on it about appropriate controls, but then talking to the suppliers of the equipment that you use, that's a really good place to start. They have information on the controls and they can really assist you in that space as well. And I think engaging with others in the industry as well is also really important.
May I add something onto that, Rob?
Yes, fire away, James.
In the spirit of consultation, I'd also encourage employers to ask their workforce, how do you think this is working? Is it working as well as we intended, or is there anything we can do to improve this? These are the people who are at the coal front, so to speak, and they understand how this equipment works and whether it is effective or ineffective. So I encourage everyone just to have a chat with your workforce. That's another indication.
Next one up is we have just conducted our first air monitoring concrete structure company for our SC. How often would monitoring need to be conducted? I'll throw to you, Halil, for that one.
The regs, in terms of regulatory requirements, I'll start there. The regs are all about if there's uncertainty in relation to the exposure standard health risk, that's when monitoring should take place. That doesn't stop an employer from undertaking monitoring annually or every so often, but it's really where a process changes maybe, and maybe production has dramatically increased, a different process has come on board, and the levels are no longer what they were or when monitoring had taken place last time. So if a change occurs, reevaluate, are we still, is there any uncertainty now?
Okay. So it's like, it's not a set and forget. If
No.
something changes, you need to kind of go look at it again to see if there's anything changed in the outcome.
Yeah, okay. That's right.
Thank you. Do you have a definition of what is classed as high-risk silica work versus other silica work that isn't high risk? Halil, I'm going to put that one to you as well.
Well, I suppose I just come back to the definition in the regulations. High-risk crystalline silica work is a specific term that's used in the regs, and it's defined essentially as undertaking a crystalline silica process, which is what we're talking about before, power tools, etc., generating dust, and it's likely to be exceeding half the exposure standard. So with the footnote, you can't consider controls when you're making that assessment. So if we see someone cutting concrete on the footpath, they're using a power tool, they're cutting into concrete, concrete contains crystalline silica, they're generating dust, however, they've got it well suppressed. There's no dust that's in the air, it's being controlled, etc. However, we look at that process and we imagine no controls, and that's using a power tool on concrete, generating crystalline silica dust, and it would be a lot of dust that's created and likely to be exceeding half the exposure standard. So that's high-risk crystalline silica work.
Thank you. How do we shift the focus off RPE to the sole control in construction? Sorry, as the sole control in construction. James, I'm going to ask you that. I'll ask it again. How do we shift the focus of RPE as the sole control in construction?
I think it's all about having these conversations and getting out and doing as many webinars and toolbox talks as we can, but also having chats with your mates in construction. We all pretty much do, kind of similar work in construction. And as long as we keep talking about this and keep sharing the messaging out there and keep getting these wins on the board like we're having, I went out to a few workplaces the other day and they've implemented engineering controls. It was fantastic to see. So I think having the conversations, building up that awareness is how we can elevate this conversation from the PPE level up to the engineering level.
Can I add? Sorry, go on, Potato.
We go to Potato first and then we'll come to you.
I was going to add that the crystalline silica has a control statement, I think also really supports this as well, because you have to document what your controls are. So immediately when you see it written on a piece of paper, and again, consulting with the workers as well, you can go, we've just got PPE on a piece of paper. Maybe we should be asking a question further up. And so I think that's another opportunity to go, well, what are we actually using here to control the dust? Hello.
Yeah, I just wanted to add, I was actually talking to James a bit about this earlier, and it was since the regulations have come into effect, there are more and more higher order controls or power tools with on-tool extraction and wet suppression that are available on the market. 5-10 years ago, you may have said, oh, it's not available, but now they are much more readily available as well.
And just to bookend this conversation, I might just finish with this. I strongly encourage the employers out there to go out and do your research. Don't grab the first thing that you see on the shelf. Really consider what is going to be the best fit for your workplace, because this is an investment, into your workplace, into your workers' health and safety, and you want to make sure it's the right investment. So,
thanks for that, James. Next one up are there baseline levels of the amount of crystalline silica available per task, i.e. drilling into a concrete ground in the outdoors?
I wish. I think that would be very simple, but there's various studies, and you sort of can do a little bit of research to understand, but there's no absolute. We're looking at trying to sort of collate some data, but there's no absolute at the moment. It's really doing a little bit of research, seeing if other studies have been done that are similar to your activity, and seeing what sort of numbers that they've been able to generate, or that those processes generate, and being able to relate it to yours.
Thank you. Does sweeping up concrete slabs require controls? And to clarify, not dust specifically created by cutting, drilling, but normal building site dust. James, I'm going to ask you to step in on this one in the first instance.
Yeah, no problem. So I have seen atmospheric monitoring results. This is from a concrete dust perspective, not a general sort of, debris sort of perspective, but I have seen results from sweeping up concrete dust and other sort of dust containing crystalline silica, and those results are quite high, startlingly high. But from a general dust, or general debris perspective, it's hard to say what is in that. But from a concrete dust perspective and from a silica dust perspective, I have seen high results from that. What I would encourage people to do is look at maybe low pressure hosing. So low pressure hosing down that slab to contain and suppress those levels of dust.
Why low? You say low pressure. Why low pressure?
So when we look at a high pressure, like a gurney or something like that, that will actually cause the dust to become airborne again. And that's when you have that secondary exposure. So a low pressure hosing, something that will sodden the area and keep it suppressed, that's a good option. Alternatively, if you have an M or a H class vacuum, you may want to vacuum up some of those finer particles of dust and maybe pick out some of those bigger concrete chunks, or maybe some offcuts of wood or something like that. So they're your two options I would recommend.
And again, I get the sense of, one is, in some ways, could you say that the suppressing is a low end, and moving into the more vacuum with the proper filters on it, that's starting to move up the line again?
Yeah, definitely.
Okay, thank you.
I was just going to add to that, Rob. Sweeping, again, also comes under crystalline silica processes, but it's one of those tasks where that really fine dust gets into the air and you can see the dust just hanging. So the thing with respirable crystalline silica is, because it is such small particles, it can literally hang in the air for hours and hours on end. So sweeping doesn't just create a little burst of dust that you get exposed to once, it can actually suspend it there for a long period of time, and people continue to get exposed as well.
Thanks, Bernita. Can we include the hazard control statement within the control measures with SWIMS? James, I'll lead in with you on that one.
Fantastic question. Yes, so the regulations recognise that a lot of people work with SWIMS and they're not dissimilar from each other. So absolutely, if you're using a SWIMS already, say you're working above 2 meters, you can include that silica perspective within that SWIMS. So there is no problem there. Absolutely.
And does that go in some ways to the question we spoke about earlier on? And some people may say paperwork isn't a priority, or can be confusing or time consuming. Being able to bring those two together appears to me, on face value, to be a good thing.
It is. And it's really that, like I said, this is meant to be beneficial to the worker. And if they just have to refer to one sheet of paper, this is the plan, this is how we're going to do the work, I think it's a win-win situation.
Thank you. Next one up is, would you expect silica monitoring on construction sites? I'll throw you in on that one.
I think we've spoken quite a bit about exposure monitoring. So obviously this is something that a lot of people have got questions on. I'm probably going to talk about what Hillel's spoken again. So really where there's that uncertainty. So potentially you haven't done air monitoring before, or maybe you've put controls in place and you still are uncertain if it's actually controlling. I mean, one of the other things with construction is that some of the tasks might produce significant amount of dust. So it's important to make sure that those controls are working effectively, and you might have that uncertainty after you've implemented controls that they are controlling the dust at those levels. So yes, I think we will see more exposure monitoring being done at construction sites. And I think that's really important, not only from an understanding the dust as an employer, but also communicating to your employees. So it's really great when air monitoring is done, but think about how you communicate those results to the employees, because they're the people that are being exposed to the crystalline silica. So if you get a report, make sure you understand it. Make sure that you can confidently talk about it to your employees, or maybe you need your hygienist who did that air monitoring to support you with that communication as well. So everybody is really clear and understands what that level of exposure is.
And may
I
I
think that,
add,
go on, James.
sorry, Rob. I may just touch on something that Halil brought up earlier. You may wish to just assume that you're going to be above the control exposure standard and adopt controls from there. So you may have some resources and say, you know what, we want to put this into controlling the risk rather than assessing. You can jump that assessing and go straight into control. So that may be something that business may want to look at.
You know, where I was going with that as well as James is you made the comment earlier about consulting with your workers about the control measures, asking them what they think. And Pradita was just kind of reinforcing that it's not just about the control measures, but the information. So if you have got results, the sense I get is that constant communication and consultation with your workers in that space to say, well, what have we got? What are we dealing with? And what controls are adequate for us here? I think that's probably more of a statement than a question. We'll get on to the next one. So, can you please explain the TWA for exposure from an 8-hour workday to the common 10-hour workday in construction? I'm definitely going to give that to you, Lil.
The time-weighted average is an average over a shift. So the exposure standards are based, the respirable crystalline silica exposure standard is based on an 8-hour time-weighted average, meaning you can be a little bit above at a certain point in time, then a little bit below, but it's the overall average is what you measure. So you might measure for a period of time and then average it out over the 8-hour day. There are shift adjustments that can be made for extended periods of time. So if you've got a longer period and you're regularly working, 10-hour days, etc., you can make those adjustments, and there are models to be used for different sort of adjustments that can be made, and it's really about there being adequate breaks between the periods of exposure, that sort of 40-hour week type of exposure, and a knock hygienist that's experienced in this area would be able to easily undertake that monitoring and then make that adjustment and then present it in the monitoring report to say the standard that you're looking at because of your shift length and duration, etc., is different, and this is the number that's the key number for you.
Pradita, I'm actually going to go to you on this one. Is there legislation in place that states employers must undertake health monitoring for high-risk workers?
So I'm going to be careful with the language that we use here. So we've spoken a lot about high-risk crystalline silica work and that being at half the exposure standard. So when we talk about health monitoring and the need to do it where it's reasonably likely that employees may have adverse health effects due to the silica exposure, what we're looking at there is kind of where we've got levels where employees are reliant on lower level controls, i.e. respirators, to keep their exposure to a level below the exposure standard. So again, respirators bring that lower level of control. We know with those lower level controls, it's not consistently put on. So an employee may be trained, they may be fit tested in their respirator, but they may not put it on correctly every single time. So that's another issue with those lower level controls. So in that situation, health monitoring is needed for the employees. And when we look at the health monitoring, engineered stone has a slightly different requirement but if we're talking the construction industry, health monitoring needs to be undertaken in supervision of a medical practitioner. So it's going and talking to a medical practitioner. Again, if you have done air monitoring or you have a knowledge of what you think your exposure levels are at your site with the work that's being done, take that to your medical practitioner because that can help them inform what the health surveillance will look like for your employees.
Here's an interesting one. Actually, we did hygienist testing. We confirm if the extraction tool is used, then exposure is below 0.25, but we still need to wear PPE. I think that's a question. So they did the hygienist testing, confirmed that the extraction tool is used, the exposure is below the 0.25. Do we still need to wear PPE?
Yeah, there's, I think 0.25 is probably 0.025. 0.05 is the exposure standard, half the exposure standard, 0.025. Now, the must-dos, if you like, in terms of the regs and controlling the risk. So we're talking about exposures that are likely to exceed the exposure standard. If they're saying exposures are not likely to exceed half the exposure standard, we certainly would not walk into that workplace and say, you must implement a control and PPE is one of those controls. We'd certainly encourage high order controls and work your way down to minimize exposure or reduce exposure as much as reasonably practical. But in a situation where exposure is not exceeding the exposure standard, we would not be enforcing, like must do, the need for additional controls or PPE in that sense.
Thank you. Next one up we have is, what's the ppm and PEL for sand, tile, grout, concrete, bricks, mortar, etc.? Are hygiene assessments required? First off, I suppose someone obviously knows the acronyms with ppm and PEL. Helen, would you again answer?
Well, I'm not sure in this context, actually. ppm is sort of parts per million. Sometimes you can equate that to the milligrams per meter cube when you're looking at exposure standards, but really we're looking at milligrams per meter cube when it comes to respirable crystalline silica. And was it the PEL, the other one, Rob?
PEL, yes.
Yeah, maybe PEL sometimes is referred to as permissible exposure limits, but once again, we don't use that. We use, your time weighted average, your threshold limit values, TLVs. So, so really we're talking, once again, we go back to the exposure standard, 0.05 milligrams per meter cube, and then the cutoff of half that for a high risk crystalline silica work of 0.025. Was there mention of materials as well in that question?
They mentioned about sand, tiles, grout, concrete, bricks, mortar, etc.
So maybe the question...
I'm wondering if you reframe it. Yeah, I was just wondering if you reframe the question. It goes back to what you're saying about the risk assessment. If you're not sure, undertake the risk assessment and go through those factors.
And maybe the question is really trying to tease out, how do I know how much crystalline silica there is in the product that I'm working with or using? And that's a valid question. And really, if I'm using bricks, go back to the people who supplied you the bricks, the manufacturer, they'd be able to provide you with information, and they'd be required under these regulations. If it's mortar, if it's concrete, if it's material that's being supplied to you, they would be required to provide you with information on that. And then where that information is not being directly supplied, Google is a brilliant source sometimes. try and check your sources, obviously, number 2 or 3 times, but try and establish through what's the likely levels of crystalline silica in the material that you are using. And WorkSafe has got information on that for various substances as well on our website.
Thank you. Does WorkSafe provide SWIMS templates for control for silica? Pradita, I'll actually go to you on that one.
Yes, so we do have templates available on the WorkSafe Victoria Silica website. So there's construction areas there, and you can get the template for the crystalline silica hazard control statement as well.
Thank you. And are there control standards for disposing of the collected dust and debris? James, I'll actually go to you from your experience in construction.
Yeah, so from my perspective, waste management or the secondary exposure that may come from the handling of the waste products is something that we don't look at. We tend to focus more so on the immediate exposure, the immediate generation of that dust. But if you're using an M or H class vacuum, you'll be putting it into a self-cleaning bag within that vacuum unit, or you'd have a sausage casing if that's what type of vacuum cleaner you are using, in which case you would gooseneck it and tape it up. You would dispose of it in a general bin in accordance with local council regulations. There are also some companies that provide dedicated silica bins, and that may be if someone's handling large BESA blocks or large bulky items and chucking them in the bin, it may burst a bag and create, again, that secondary exposure. So that may be something that you might want to weigh up at your particular workplace to see if there is that risk there.
No worries. Thank you. And I think we have time for one more question. Are there different requirements for Victoria and New South Wales regarding the inclusion of silica hazards in SWIM or hazard control statements? Pradita, I'll throw to you first to see if you can answer that one.
So I obviously know the Victorian regulations very well, and we're not New South Wales, so I'm not quite sure on the New South Wales requirements. But I think that consistency with SWIMS, which is that requirement to identify hazards and risks and controls and how you're implementing them, is consistent. Definitely in Victoria, we've got the crystalline silica regulations that then call it out specifically. But I think from a New South Wales point of view, obviously check what they've got available and ask them the question.
Thank you. Now, I notice there's still more questions that we'd love to get through, but unfortunately we're out of time. So if you want, please send them through to us through our advisory line. We're quite happy to get back in touch and answer them for you. So first off, to Pradita, to Halil, and to James, thank you very, very much for participating today. I think, I hope everybody finds this as an engaging, informative, and an interesting session. So thank you to you three. This webinar will be available next month on WorkSafe's website. You'll note on the screen shortly, any of the information that we referred to today or material or guidance material should appear on the screen for your use. And if you have any requests, just like I said, if you have any requests for further information, please feel free to get in touch. And remember, if there is something that you'd like to urgently speak to us once you get back to your workplace, please contact us through our advisory line or emergency response line. And with that, on behalf of WorkSafe, thank you all today for being part of this webinar.